All right, let me walk you through the changes you're going to need to make to the lab in order to do the e-learning day virtual simulation version of it. So first of all, anytime it talks about Marble and tracks and things like that, you're going to be using the online simulation. So don't get confused by the wording. It's written for a lab we do in class with marbles on ramps. You're not going to be doing that. You're going to be using the Energy Skate Park simulation that we've used before. So when you get to the Energy Skate Park simulation link, you want to click on the play. You want to select playground. And then you're going to need to turn on several things. You'll want to turn on grid and reference height. You'll want to make it slow so it's easier to record your measurements. You're going to want to turn speed on, and you're going to want to leave it so that it sticks to the track, and leave friction so that it's 0. That's going to make things a little simplistic for us, but there's no point in making it more complicated just for complicated sake, unless you want that, which case just turn a little bit of friction on if you want it to be a little bit more realistic. It won't have any adverse effects on your overall thing. It'll just add a little bit of air and uncertainty. So it's not a bad idea to add in just a little bit of friction to it. So anyway, once you have that all set, you're going to need to make 4 tracks for your person to go on, and they're going to look like this. So you're going to have 1 track, and I started all of mine at 7 meters. You can start yours wherever. The higher you start it, I think the better it's going to be. And you want to try to end it as close to the ground as you can. So 1 is going to go at a steep curve down towards the bottom. 1 is going to go in a straight line steeply towards the bottom. 1 is going to go in a straight line at a more gradual line towards the bottom, and then 1's going to start out very slow and then go very steeply towards the bottom. So you should be able to get all 4 tracks on there. Okay, so that's what you're trying to do as far as the setup goes. So when you get into the lab, measure the height of the track. That's going to be where you start. You're just doing it in meters. Measure the mass of the marble. It's going to be the mass of the person. That's already in kilograms, so don't worry about centimeters and grams. You're going to do your calculations here. The equations are on the lab, so you should be able to find what you need. Calculate work, calculate potential energy, talk about the answers, and then decide which of them is going to go the fastest at the bottom. Now, when you get down here to the data table, ignore distance, ignore time, just do velocity. What you'll do is you'll start your person on the track as close to the top as you can, let them go, and then what you're going to do is you're going to pause it when they get to the bottom. So I'm letting him go, let 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 him go. When you get to the bottom, pause. Write down what that speed is, go over to your lab, type that in for your first velocity. You need to do that 5 times. Now, the tracks are listed as red, blue, yellow, green. It really doesn't matter which is which, just as long as you know which is which. So you might want to change it from red, blue, yellow, green to maybe steep curve, steep straight, shallow straight, shallow curve, or something like that. Something so that you can tell the difference between them. Record your 5 velocities, average them, and calculate kinetic energy. Okay? Then you're going to calculate talk about why'd you only calculate the potential once, and then you're going to compare your kinetic energies. So they're almost certainly not going to be exactly the same, even if they should be. So what you're looking for is how close are they? If they're within 10% of each other, you can assume they're all supposed to be the same, but they're not going to be perfect. And again, as I was mentioning, I would turn on a little bit of friction just to make things less sterile. Otherwise, it's going to be just off of your reaction time. If you add a little bit of friction, it'll add a little bit of change into the lab. Don't even need to put that much, but adding a little bit of friction, I think, will make it a little bit more realistic and make it seem to make more sense. So if you put just a tiny bit of friction, that may help a little bit, especially when you get to talking about errors and that sort of thing. Then you're going to find the percent difference between potential and kinetic. If that number is close to 0, then you can assume energy is conserved. Now, because we're doing it on a simulation, energy should be conserved. There shouldn't be any funky stuff. There shouldn't be weird stuff. It's not going to be 0, but it should be pretty small. So unless your numbers are really off, you should be able to skip 11, 12, 13, and 14, and 15. Because your numbers should actually show that you conserve energy, because that's what the whole point of the lab is. And so then you would do 16. So to kind of sum up what you're doing, you're making the 4 different tracks, turn a little bit of friction on. You're going to start your person at the top of each track. You're going to let them go down, and you're going to measure to see what their speed is when they get to the bottom. Okay, going to write that number down in your data table. Do all the calculations, talk about potential energy, talk about your kinetics. Remember, if they're within 10%, you can assume they all should be the same, even if they're not exactly. And then calculate percent difference to see if energy is conserved. Don't forget to do number 16. You're skipping 11 through 15. Don't accidentally also skip 16. You do need to do 16. So make sure you're doing all that. If you have trouble, if you're getting stuck, if you're confused, if you're not sure how to do the math, send me a message on Schoology or send me an email. Office hours are going to be around 1 o'clock-ish until whenever, till 3 o'clock, till 2 o'clock. It's going to be during my kids' rest time. So that's about the time it'll be, around 1 o'clock, for about an hour and a half to 2 hours, just depending. Okay? Let me know if you have any trouble with the lab. Otherwise, good luck and have fun.